Chapter 2, Unique Characteristics and Capabilities of Software. When we look at manufacturing and the accomplishments that they are able to achieve by creating a systematic approach to improving how they developed both products and processes, it's important to understand that software has some very unique characteristics and capabilities that would require taking a different approach. The type of work that you do in software development is different, and you're really dealing with a digital asset instead of a physical asset, which has some significant implications. And software development, relative to what's been done in manufacturing, is relatively new and is an ongoing thing. Type of work. The type of work that we do in software is very different. There's a few different types of works, and the way that we improve and get more effective at these different things depends on the type of work that's being done. One of the types of work is the new products and new features and new capabilities that we're trying to write and create within software. And this is the types of things that you tend to do. Most of this work is very manually programmed, written by individuals working with the business, trying to understand that and working through those. The second type of work that we do in software development is triage and defect fixing. This is the process where we go through and we look at everything that's been created for the new product and new features, and we look for any defects that have been associated with it, and we go through a process of finding those defects and fixing them. This is very unique with software development because being a digital asset, it's hard to see these things, and triage is difficult. A lot of the large organizations that I work with, in fact, spend more time and effort in triage and defect fixing than they even do writing the code in the first place. And this is one of the opportunities for significant improvements, is thinking about how do we make this triage and defect fixing more productive. The next type of work that happens in large software organizations are repetitive tasks. These are things like create an environment, build the code, deploy the code, and test and validate the code. And this really is the manufacturing process for software. This is where we take everything that's been written and we assemble it, we create it, and then we validate that it's ready to go. The approaches that we use for these repetitive tasks to improve them can leverage a lot from what was done in manufacturing. Where they've had a lot of repetitive tasks, they tend to automate those things and make sure they're stable on an ongoing basis. And for software development, this is a real opportunity for automating these things so that you get consistency, you get repeatability, you get reliability along those paths. So the types of things that you do for addressing repetitive tasks is very different than the types of things that you do to address improving the effectiveness of triage and defect fixing. And is very different than the types of things that you do to improve the manual creation of code in the first place. There is also repetitive tasks that occur on the ongoing operations. Google in their SRE book did a really good example and opportunity showing how that they have fundamentally changed not just how they create the software with the manufacturing process and repetitive tasks, but the job of everybody in operations is to start figuring out how do they automate more of the types of things that are repetitive from an operational standpoint. And then the last type of unique work that happens in software is the improvement efforts. How do we go off and figure out what are the types of things to improve in the process? How do we prioritize those, and what are those changes? And as we make those changes, how do we make sure that we don't break other things in the process? Digital versus physical. One of the most unique things about software compared to manufacturing is we're dealing with digital assets instead of physical assets, and that has a lot of broad implications. First, when you're dealing with physical assets and you want to start creating and manufacturing prototypes on an ongoing basis, that's an expensive process and it takes a lot of time to do and create. So typically your early things you do with 3D printing, or you do with hand-built prototypes or something along that path to make those more efficient. With software, that manufacturing process of creating an environment, building the code, deploying the code, and using it on an ongoing basis is very easy to create from the first line of code. therefore, for software development, you really don't need to have a line between when you're developing the process and when you're writing the code. So you can continually start creating that from the beginning and improving it. Additionally, there is no FGI, finished goods inventory, with software. Because it's digital, you can make as many copies as you want. And because it's digital, you don't have to worry about building up a lot of inventory. So for each change in the software product, you can do a full manufacturing build, release, and have it ready to go and out the door, which is important because with software, 50% of the time, what we thought was going to be effective or achieve a specific business results ends up on software that's either never used or doesn't meet its business intent. So this idea of being able to manufacture it from the beginning, change it whenever you want, is really helpful when you think about that we need to figure out how to build more of the stuff that's going to be used and how do we build less of the stuff that's not going to be used. Another thing that's really unique with digital assets is it's hard to see. With physical aspects, you can walk into the factory, you can walk around the factory, you can look at inventory building up on the floor, you can look at two pieces being assembled together and figure out if they're a quality problem. With software, it's really invisible. You can get down the lines of code and you can't really see work flowing through the system, and you can't see how the product comes together very well. The other thing that's very unique to manufacturing from a process standpoint is with manufacturing, you're trying to build the same thing over and over again with as limited variability as you possibly can. And with software, what you're trying to do is every time you run your manufacturing process of give me an environment, deploy the code, or build the code, deploy the code, and run a test, the product is changed. And so that has broad implications on using the scientific method for continuous improvement because you're changing both the product and the process at the same time. The other thing that's unique about software is that once you've got the repetitive task automated and stable, the primary thing that you're trying to find are product defects caused by manual work. Somebody has coded something in such a way that had an implication that you didn't understand, and that's a product defect not caused by the process, but caused by an individual writing code. The next significant challenge with software is because you're changing the product with every revision of the process, one of the big challenges is we need to figure out how to make and enable the process to change at the same rate that the product is changing. Software maturity. One of the other biggest differences with software than manufacturing is it's relatively new. Because it's new, there are a lot of things that are changing very quickly. From my experience working in manufacturing and product development, and then moving over into software, one of the things that I really became aware of is just the difficulty with planning and predicting software. And this is something that I'd intuitively learned. And it really hit home with me when I was spending some time with Martin Fowler, and he explained to me that his wife is a civil engineer. And that after years of thinking about it and working through, the only way that he'd really been able to describe software development to his wife as a civil engineer is that it's like the properties of concrete change every 2 years. Now go plan the Hoover Dam. And in a lot of respects, I thought about that and spent some time with it and went back and looked at it. And realistically, the languages, just the base technology used to write code, has been evolving at a very dramatic rate, as you can see in the figure below. The types of languages and what we do with it is different. The process has been changing fairly dramatically in terms of what you can leverage for the tools, for DevOps, for being able to automate some of these repetitive tasks are fairly new. And just the whole processes and approaches to changing how we do development. Agile didn't come out until 2001 and was really some of the first steps to treating software differently, and that's changing at a very fast rate on an ongoing basis. which makes it much harder to do an accurate plan very far into the future for software. And there's a couple of really big changes that have happened fairly recently that have had a dramatic effect on software. One is the virtualization of hardware, where we've really been able to separate even more of the physical and the digital assets. It used to be, before the virtualization of hardware, when you planned a software product, you needed to also bring in the hardware to do it, plan, there were lead times, all that behaved much more like a physical asset and going through that process. But when we've been able to decouple the physical and the digital with virtualization and internal data centers or the cloud capabilities outside of it, we've really been able to treat the majority of the software that we have as a digital assets, which is much more flexible. And then probably one of the biggest breakthroughs to hit the scene more recently is just the automation of the repetitive task. And this kind of came together. There were some early things when it really came out with John Allspaul's presentation at the Velocity Conference of how often they were able to deploy code into production. And at a similar time, David Farley and Jez Humboldt came out with their seminary book on continuous delivery, which really set the ground stakes for being able to automate a lot of these repetitive tasks. And these types of things, these ideas weren't available in the industry before then, and they have a broad implication on how software behaves and the types of things that you can do with it. So software is different than physical assets. There's a lot we can learn from manufacturing, but the type of work we do differently. The type of work we do is different. The fact that we're dealing with digital assets versus physical aspects has pretty broad implications. And the fact that we're dealing with a relatively immature process or technology that's evolving at a very high rate has implications across the system. So when we look at software and we look at trying to come up with a systematic approach for how we make improvements, we can really learn from manufacturing, but we really need to take in and incorporate these differences that exist.